In this video, we will continue with 2 more worked examples on writing selection statements. The subgoals are dependent upon whether you are writing an if statement or a switch statement. The first subgoal is the same for both statement types. First, we define how many mutually exclusive paths are needed. Then, the paths and the type of variable will determine if you use an if statement or a switch statement. For an if statement, the next subgoal is to order from the most restrictive group to the least restrictive group. Then, write an if statement with the Boolean expression. We follow with the true bracket, including the action. We then follow with the else bracket, including the action. Then, we repeat until all the groups and actions are accounted for. If you're using a switch statement, after you determine the number of mutually exclusive paths, you then determine the variable or expression for mutually exclusive ranges. Next, write a switch statement based on the variable or expression. Each range is a case. And finally, include break statements and default case if needed. We are given the following problem. Write the Java selection statements to solve the following specifications. Write the statements to print out the name of the month equivalent to the value stored in the integer variable month. For subgoal 1, we need to define how many mutually exclusive paths are needed. In this case, there are 12 different months. Each value is represented by a unique value, 1 to 12. In this case, a switch statement will work. For subgoal 2, we are asked to determine the variable or expression for the mutually exclusive ranges. We want to base it off of the integer variable month. For subgoal 3, we write the switch statement based on the variable or expression. So we have switch on the variable month, followed by the open and close curly braces. For subgoal 4, each range becomes a case. Because month is an integer, all of the case values must be integers. For this problem, we will have a case 1, a case 2, a case 3, and so on, all the way through case 12. For each one of these cases, we want to do the action associated with that value. So for case 1, we want to print the string January. For case 2, we want to print the string February, and so on through case 12, which prints December. For subgoal 5, we include the break statements and default case if needed. In this problem, we want a break after every case, because we want it to print only 1 month string value. We are also going to add a default in case the value in month is not 1 through 12. In that case, we will print the error message that there is an invalid value. Here is another worked example. Write the statements to print out the letter grade equivalent of your quiz grade. 90 through 100 inclusive is an A. 80 through 89 is a B. 70 through 79 is a C. 60 through 69 is a D. And below 60 is an F. For subgoal 1, we again define how many mutually exclusive paths are needed. In this case, there are 5 mutually exclusive paths, 1 for each letter grade. You may use a switch statement, but note that you will have to give each numeric grade as a case, since relational operators, less than, greater than, equality, are not allowed in case statements. Or you can use nested if statements, which is what we will use. For subgoal 2, we order from most restrictive to the least restrictive group. In this case, the most restrictive is for those who scored 90 and above, then those who scored 80 and above, then those who scored 70 and above, and so on. Now we want to write the if statement with the Boolean expression. So we have, if the quiz grade is greater than or equal to 90. For subgoal 4, we follow with the true bracket, including the action. So now we have, if the quiz grade is greater than or equal to 90, we want to print out that the student would get an A. Now we follow with the else bracket. In this case, our else leads us to another condition. Else, if the quiz grade is greater than or equal to 80, we want to print out a B. We do not need to add the condition, and quiz grade is less than 90, because we already accounted for those values with the first Boolean condition. For subgoal 6, we repeat until all groups and actions are accounted for. So we need 1 for if the quiz grade is greater than or equal to 70, 1 for if the quiz grade is greater than or equal to 60, and then our final else, which would print an F for anything less than 60. Here is the equivalent answer written as a switch statement. You could switch on the quiz grade, and you would have 1 case for every numeric grade. You would then use a default to print out an F.